Alright, now it's time to talk about the ionic charges that these ions will get. Okay, so remember, with ionic charges, things either want to go down to 0 or up to 8, with 4 being in the middle. So anything that is 1, 2, or 3, has 1, 2, or 3 valence electrons, is going to give those away and go down to 0, which leaves them with a positive charge because they're giving away negative electrons. If they have less negative electrons, they're overall going to be positive. Things that are above 4, so things with 5, 6, or 7 valence electrons, are going to want to take more electrons and go up to 8. Taking more negative things means they will have a negative charge. Things that are already at 8 are happy, so they're not going to do anything. Things that are at 4, they're generally going to share. Sometimes some of these in group 14 will take a 4 charge, or like lead can also have a 2 charge. Basically, don't worry about these guys. They're either going to be covalent, or I will tell you what charge they have. So don't worry about group 18 because they don't do anything. Don't worry about group 14 because they're right in the middle, and either they're going to be covalent or I'll tell you the charge. So all you have to worry about is groups 1, 2, and 13, which has 3, and these guys, 5, 6, and 7. Okay, so let's look at the different charges of these guys. I'm going to use the same ones I did last video with the dots to help us easily see what they're going to do. Let's start with sodium. Sodium's right here. He has 1 valence electron, so that makes him fall right here. What is he going to do? Give it away to go down to 0. He's going to be positive. Okay, so he's going to be 1 positive for his ionic charge. Let's jump over here to chlorine. If you look at chlorine, it has 7 valence electrons, so what's it going to do? It's going to take to get up to 8. How many does it take? It's going to take 1, because it's only 1 away from 8, right? So he's going to take 1. That means he's going to be 1 negative for his charge. So that's chlorine. How about aluminum? There's aluminum right here. How many does he have? 1, 2, 3. Alright, so he's 3. Less than 4, he's going to go down. He's going to be positive. If he gives all 3 of those away, that means he is 3 positive. How about silicon? Oh, I told you not to worry about silicon because he's in group 14, so we won't worry about him. Just draw a smiley face. Alright, how about oxygen then? Oxygen has 6 valence electrons. That's on this side, so it's going to... How many is he going to take to get up to 8? He's going to take 2. So he's 2 away from 8. So that'll be 2. Is it positive or negative? He's taking negative electrons, so he's negative. Alright, what about strontium? Strontium here only has 2 valence electrons. So it'll give them both away and get a charge of 2 positive. Who's left? Phosphorus. Phosphorus has 5. Okay, that's right here. He's going to take and go up to 8. How many does he need to take to get to 8? He needs to take 3, because he's 3 away from 8. So he'll be 3 negative. So there you go. That's how you figure out ions. If they're positive ions, you just write the charge of how many they gave away. Like aluminum gave away 3, so it's 3 positive. Sodium gave away 1, so it's 1 positive. If it's a negative ion, if it's on this side, you say, how many does it take to get to 8? To get up to 8. And that is its charge, because it's how many extra electrons it took to get up to its full set of 8. Okay? I just wanted to show you this periodic table here. The blues are metals, see? The browns here are nonmetals, and these, I guess light browns are semimetals or metalloids. And the reason this is relevant to what I just talked about is that metals here, see all these blue guys, they are all going to be positive ions and give away their electrons. Okay, so these all form positive ions. And these guys over here, the brown ones, the nonmetals, they will all become negative ions. They will all take to get up to 8, whereas these guys give away to go down to 0. These guys in the middle can act like metals or nonmetals in various different ways. Boron is not necessarily related to giving away or taking electrons, but in other ways they can act like metals or nonmetals, which is why they're called semimetals. Okay, so as you can see, the vast majority of things are going to be positive ions because they're metals.